Dear viewers, I welcome you to the class 6 of heat exchangers. What are the material you are seeing here is the thing that we have studied in class number 5. Okay, in class 5 we have studied LMTD for parallel flow heat exchanger. So now in this class 6, I'll mention you the changes that you need to make in order to get the LMTD of counter flow heat exchanger. First change is this. I'm changing the heading to counter flow heat exchanger. Then comes the diagram. This is the temperature variation for parallel flow heat exchanger. Now that will be changed to counter flow heat exchanger. This was the diagram is counter flow heat exchanger, change in the direction of hot and cold fluid, opposite direction of flow. So now here these 2 points remain same, assumption remains same, all the parameters remain same, then equation 1 remains same. Coming to the energy balance for an elemental area, we had minus dqh and plus dqc that has been changed to minus. So we have to include this minus sign here. The reason being, see here, as the length of the heat exchanger is increasing, temperature is being decreased for hot fluid. So it was minus. Coming to cold fluid, with the change in the length, with the increase in length, temperature is being decreased. No doubt that the direction of flow is from right to left, but the temperature is being decreased along the length. But it was not so in parallel flow heat exchanger. So in this parallel flow heat exchanger, with the increase in length, temperature was increasing. So it is positive. From here, with the increase in length, temperature is decreasing, so it is negative. So I'll get minus sign here. Both the dq values will be minus. This is the only change. Okay, if we change this, just the signature of minus has to be added. Minus sign has to be added for all the steps at RHS part. Fine. So in continuation, it was plus, I have changed it to minus. Fine. Then here dth and dtc was arranged from this equation, and dth minus dtc was taken. So we got this expression. It was minus in parallel flow heat exchanger. Now here it is plus. Fine, because this is minus. Minus of minus will become plus. So plus will become minus. Same minus is carried forward until the end of the derivation. Okay, minus has been carried forward. And this part, energy balance, this remains same. No changes in this energy balance equation. It remains same. I repeat, it remains same. The only change is we have added minus sign in this equation, which has been carried forward till here. Now this CH and CC will be substituted here in this equation number 2, so that we will get the next part of the derivation. Fine, plus has been changed to minus, and now the grouping should be done. How is this grouping done? In the sense, take TH0 and TCI in one of the group. Here it minus into plus is minus, minus into minus is plus. This has been changed to minus, so minus into minus plus. So plus sign for this and minus sign for this is carried. Fine. So TH0 minus TCI, what does this difference has been represented by theta 2. Okay, similarly TC0 minus THI, actually THI minus TC0 is theta 1. Here we are taking TC0 minus THI, reverse of that, so it is minus theta 1, and remaining is unchanged, nothing is altered. Fine. So only thing is, in the first step you have to take minus sign. Where exactly, I'll show it to you here. In this step you have to take minus sign. This is the only change and carried forward throughout the derivation. This is what I told you. TH0 minus TCI is theta 2 and THI minus TC0 is theta 1, but in the expression we have got reverse, that is TC0 minus THI, we have got it exactly reverse over here. So it is minus theta 1. That is the only change you need to mention. Kindly follow class number 5 and then read the things, make a note of changes in class number 6. So now to find this Q, that is rate of heat transfer, we had two methods, LMTD and NTU. Under LMTD we are done with parallel and counter flow. These two are completed, parallel flow and counter flow heat exchanger. Fine. In the coming classes we'll study parallel flow heat exchanger and counter flow heat exchanger derivations under NTU. So total we have got 4 derivations. Out of these 4, at least one is likely to be asked in your VTU examination. I repeat, at least one of these 4 derivations will be asked in VTU examinations. Thank you.